Alright, so you just sent me that you need help with like the geometry of the Lewis dot structures and figuring out what shape is what. So I'm going to help with that right now. So basically, I'm going to just write it out. So as you can tell, all of these have mx with a number. And some of them have E1, E2, E3, like, I'll explain what those numbers are. So your M, I'm going to write it over here, your M is basically the middle element of the Lewis structure. Sorry, it's hard to write on this thing. Alright, so just get that. M meaning middle element. Okay? What's your X? X, there's going to be most of the time multiple X's. X's, and I'm going to give you an example in a second. X's are the elements that are bonded to the middle element. Okay? Like if you look at all these, look at your sheet or look at this and look. All of the M's, there's only one M. Do you see that? Like CO2, there's two O's, but there's one C. So what's going to be your M? The one C, because M is always one in this case. You have three F's, but one boron. Your middle element is going to be boron because you have one boron. SO2, next one, you have one S. That's going to be your middle element. That's the one that's going to be in the middle. H2O, O is going to be the middle element because you only have one O. Does it make sense now? Your M is going to be 1. Your X can be 1 or more. It can be 1 or more. That arrow means more, just meaning more, 1 or above. So X is the elements bonded to M. Okay? So X is elements bonded to M. So M, the middle. X, elements bonded to the M. You're going to have multiple X's most of the time. Okay? They don't always have to be the same element. Like if you have C attached to N, attached to O, you have M, X2. Because you have one M, you're going to always have one M, but the stuff that is bonded to M are your X's. They do not have to be the same element. So you have two X's because there's two elements bonded to M. Alright. Your next thing, if I can make this clear, your E's are the amount of electron pairs that are extra. Extra pairs of electrons. E1, meaning you have an extra set of electrons in your Lewis structure. So if you had, let's just give an example, O, and then you had 2 here, because those are extra, you're not going to have that. But if you did, that would cause your equation to be M. You have one M, X2, 2 X's, E1, one set of electrons. Okay? Does that make sense now? Let's go on to the next element. Alright. So most of the time I feel like you're going to have this table to look at. I don't know if your teacher is going to make you memorize it. I don't know if they're going to make you not memorize it. I don't know. My teacher, I believe we were able to just look at it. So you have to figure out and be like, okay, am I able to figure this out? Let's do H2O and see why that is, what is it? H2O, the thing's right there. It's MX2, it won't let me draw, E2. Let's figure out why it's that. Alright, so you have one O, which has 6 electrons, so 1, 2, 4, 5, 6. You have 2 H's. H has 1. This one has 1. Why is there an E2 now? One second. These 2 extra set of electrons right here make it become E2 because there's 2 sets of electrons that are not bonded to an element. So that is why you write it this way. You have 1M, which is your O. You have 2 X's, 1, 2, and you have 2 extra pairs of electrons, which means E2. So you would go to your table and you would find, you have to write this formula. So you write the formula and you go, okay, this is the formula right here. Then you go across and you say, oh, it's bent 105 degrees. Then you write that down as your geometric sequence or description of shape. Alright, let's try another one. So hopefully you understand that better. I don't know. But that's just, I tried to explain it to you with a certain element. Let's try one more. Well, let's just go onto this page. Alright, so let's do some. Let's just do some. Alright, let's do an easy one. Let's do H2, because I can do that real quick. H2 is 1, then you have another H, 1. What's the case of this? X2, because there's no M. M is always, it is always going to be 1. It's always going to be 1. There is no M here, because there's, if there was, there would be 2 M's, and you cannot have that. You can't have 2 M's. So it's 2 X's. So you go back, and you say, okay, where is X2? I don't even think it's on here. Well, I feel like this one is a special case, obviously, because it's not on here, because you don't have an M. You don't have an extra set of electrons. But you would, in this case, just go along with it being this one. Because obviously looking at this shape, it's in a line, and it's going to be linear. Just, it's linear, trust me. That one's an easy one. You don't really have to, like, figure that one out, but M is always the middle element. But I guess you're always going to have M in that case. But since it's X2, you're just going to put an M there, and it's going to be linear. Alright. So that one's definitely linear because it's in a line. Sometimes you can definitely tell the shape. You just have to make sure that you're right. So, yeah. Don't always guess, though. Make sure you write the formula first. And if you get just X2, put an M in front of it, and you're going to have it. Because there's no extra set of electrons, and that's the only one it can possibly be. So, here we go. Let's try a different one. Let's try, I have to go in a few minutes, so I'm going to try this real quick. So, let's do let's do the first one. So, germanium, Ge, we're doing this one, by the way. Ge has 4, so 1, 2, 3, 4. F2, F has 7, so we're going to put it on this side. 7, so 1, 2, 3, 4, 6, 7. F over here. 1, 2, 3, 4, 5, 6, 7. Because I don't feel like doing it. Alright. Well, what do you do? Well, in this case, you are going, because you can't move both of these electrons to the middle to create a double bond. Why can't you do that? Because when you create a double bond, you have to have one electron from the middle element bonded with one electron from the outside element, which is the X. In this case, you have 2 electrons that are from both the middle element, and that will not work to create a double bond. So what you have to do in this case, erase that a little bit, you have to take these 2 elements that were here, and you have to go like this. You have to erase them and just put them on the side like that. One of the sides. And in this case, your lettering will be M, you have one M, X2, because you have 2 X's, which are your F's, and you have 1 extra set of electrons, which will be E1. So you go back and you find that equation, M, X2, E1. Bent. Okay. So your answer is going to be bent. So let's try another pair real quick before my time runs out. Alright, let's do XeF4. Xe is 8, so you're going to have Xe. 1, 2, 3, 4, 5, 6. Make that easier to see. 7, 8. Alright. So now you got, sorry you can't see it, XeF4. That's what we're doing. Now you have 4 F's, which have 7. So you have 1, 2, 3, 4, 5, 6. Uh-oh, you have an extra element. Let's put that in red. Alright, so now we're going to attach one here. F, 1, 2, 3, 4, 5, 6. Uh-oh, extra element. Attach it with that electron. Now we have F over here. 1, 2, 3, 4, 5, 6. Uh-oh, extra element. Let's just attach it over here. Oops, didn't mean to do that. Then we have another F. 1, 2, 3, 4, 5, 6. Uh-oh, extra element. Let's attach it here. So in this case, your XeF4, you have, do this in a different color. You have 1 M, you have 4 X's, which are attached to your M, and you have 2 extra set of electrons. So what you have to do, sorry, that's an E by the way, it's not an F, I just can't write it. Right, there we go. So you're going to find that MX4 E2. Square planar. So your description is square planar. Sorry, that's supposed to be like that. So that's how that's supposed to go.